Welcome, everyone. Thanks for coming to this special IEFF event. For the few here that don't know me, my name is Moshik. I'm one of the managers and the founder of the Israeli Executive and Founders Forum that you're here today. And for those of you who don't know, I guess we're now the largest professional Israeli network in America, not just in Silicon Valley. Thank you. Just as a quick reminder what we're all about, what we'd like to do here is to establish a strong ecosystem of Israeli professionals and make sure that we leverage this to share knowledge, which is what we're doing today, and collaborations, connections, advice, recruiting, and so on. So basically, the reason we're here today is to make sure that we're all connected and we can help each other in many ways, whether it's just knowledge or connecting each other to jobs or whatever else we need. The other thing, in order to get to do that, is to build simply to get to know each other. Just the basis of building these connections and advice is simply to get to know each other and just say hello to one another and so on. So just a quick reminder, in the IFF we have multiple groups. We have groups of, and they meet, sometimes they meet together, sometimes they meet separately. Founders, product, business development people, engineers, this one, life sciences, and so on. And just as a quick reminder, the IFF has lots of startups here in Silicon Valley. This is not even a complete list by any means. Maybe you can find yours, and if we forgot someone, please do let us know. And a lot of corporations are also represented here. So we also have a lot of members that come here from some of the largest companies here in Silicon Valley. Last but not least, I wanted to remind you guys that these are the physical events. This is where we actually meet in person and say hello, get to know each other, and look each other in the eye. But there's also many ways to collaborate online. Things like Facebook groups, our startup map, you can find on our website, LinkedIn. You can follow us on Twitter, and of course, Silo for those that of you that know it. Just as the last word before I turn it over to Lior to kind of get us started, just wanted to thank our sponsors for today. We have, of course, the JCC who are hosting us here in this room. Wilson Sonsini, Bank Leumi, the Israeli government is contributing and helping us here. Google, the IAC, the Israeli American Consul, and special thanks today for Hire IO, which brought the drinks and the beer. So thank you very much. Yaron will tell you a little bit about what they do at Hire IO at the end of the discussions. So with that, I'd like to leave it at that and invite Lior from Tikal. Lior is very well known for those of you in the space. There's a good company, does full stack development, and he also has a very large group in Israel of full stack meetups, and probably no better expert than to share his knowledge here today. So thank you very much, Lior.
Welcome. My name is, as Moshik said, Lior, and I'm from Tikal. Today we wanted to bring full stack developers community here because we believe that sharing knowledge is very important. And although we are coming in front of a commercial company called Tikal, we would like to present the full stack developer community here. We are doing over 100 meetups in Israel. We are over 5,000 members, developers. We speak code, we share, we discuss. And today's event, we would like to take a domain which we believe is very, very trendy today, which is called microservices, and try to break it into pieces and try to establish a practical point of view for it. So we have 3 lecturers today. Avi will start with introduction, probably not a typical introduction to microservices. We'll continue with Yanai, which will try to take a monolithic application and break it into microservices and do it one step at a time. And we'll end up with Chagai, which will do the real stuff and take all the software into the cloud, into Docker, and establish a DevOps pipeline. We love discussions, although it's presentation and we have a computer, we're in front of a computer. We we'll ask you to ask questions while presenting, and we hope you join. It's our first time, and our English is not, there's some accent, but we believe it's for us, for other of us, is the first time that we speak in English in front of the audience, so give them the chance. Let's go.
I'm going to do an intro to microservices, and I was encouraged, I would say, by the other two lecturers today to make it short. So I will try to do it as short as I can. Yeah. So my name is Avi Tzurel, and I am Ken Sodev on Twitter and any other social network, and I am open to any positive feedback that you have. If you have a negative one, please keep it to yourself. My blog is avi.io, so go check it out. If you have questions during the lecture, feel free to ask them. Don't save them for later. There might not be a later, so just ask them. And if you feel there is something that needs a longer discussion, just tweet at me, and I'll answer that later. Some minor fair warnings before I start. One is I say the F word sometimes a lot. I am not aware of that. I don't do it on purpose, but I sometimes do. I ask that you forgive me. Another one is that, so again, if you have any questions, please don't save them for later, and I'll ask them. I'll kind of answer them as I go. I am very passionate about microservices. So, often I will say something and, I'll address it as the ultimate source of truth. That's just my opinion. So, I believe microservices are the future for almost any startup out there. As long as you're, kind of big enough to make good use of them, I believe they are the future. But before we even start to dive in, let's go to the definition of microservices. So microservices are software architecture style in which complex applications basically communicate with each other. That's from Wikipedia, not from me. A lot of smart people talk about microservices. So Sam Altman from YC Combinator is doing building microservices, a talk. Adrian Krokra from Netflix, basically just read everything that guy said and everything on video. And one thing that I kind of emphasize here is that in Netflix, all microservices are context bound. So I'm gonna relate to that a lot during the lecture today. And Martin Fowler, just go to his blog. He's a very smart guy. Some less smart guy, as myself, talked about microservices for a long time now. I did, I think 2.5 or 3 years ago, I did a talk called Scaling and Expanding Your Application Through Messaging. So that lecture is online. If you Google it, you'll probably find the video. And it probably shares a lot of what I'm going to talk about today. So if you feel you need to, just go there. One thing that, while I was doing the research for this talk, I was looking at AWS reInvent event, and I was looking at lectures from 2014. I was looking at lectures from 2015. And the thing that stood out the most, other than the depth of the lectures and the variety of the speakers, was that from 2014 to 2015, there was about 150% increase in talks to discuss microservices. So that was interesting, and I was kind of, I said, wait, how is that even possible? Because we were talking about it for a long, long time now. So how is that even possible? And then I saw this talk from SoundCloud, this blog post that how we ended up with microservices. And I said, wait, SoundCloud has been in business for a long time. They probably have services, for a long time. So I was looking up at Google Trends, and I was like, wait, microservices, when did that start? And the interesting thing is that it started late 2013, early 2014. And again, I was kind of confused. Like, we're talking about service-oriented applications and microservices for a long time now. What really happened here that it started taking off? And then I realized that it's kind of service-oriented application versus microservices. So people, started talking in microservices other than service-oriented applications. So I started kind of looking into the correlation, what really happened in 2014 that made people talk about it more. And the only thing that I could find was that in 2013, I think mid-2013, gay marriage has been legalized in the United States. And I was like, wait, that couldn't be related. That's really not possible. And I tried to find more events and more stuff that was really kind of relating to microservices. And the thing that I found was that all of these companies started talking about microservices with Docker, right? When Docker started in late 2013, early 2014, that's when the kind of discussion moved from service-oriented application to microservices. But before we start, let's get rid of the usual, whether microservices are good, whether they're not. So a lot of people are doing microservices now. A lot of big, companies are doing microservices and putting kind of all their, financial resources and all of the engineering resources behind microservices. So I kind of want to get rid of the usual of, that's a proven field. We don't really need to kind of prove whether microservices are good or not. But what does this say about you, really? It doesn't really say anything about you. And trust me, I'm an engineer. So let's dive in a bit. But before we dive in, let's just make sure that we don't drown in the world of microservices. And let's make sure that we don't end up like these guys trying to balance an excavator on a boat. So before we kind of dive in, let's ask ourselves, do we really need to go into microservices, right? So the question that really comes to mind and asked about every time I do a talk about microservices, every time I blog about microservices, every time I tweet about microservices, is when do I know I need it, right? Because when you're bootstrapped and when you're just like two engineers, I think microservices are over-engineering and over-complicating things. So I thought about like, what are clear events that I know that happen in my company that I can, reliably say microservices are now the solution. So these are short ones, right? One is development time versus development handoff time, right? So when I'm looking at, an engineering team, there is like the client-side team, and then there's the API team. And as the application gets bigger and bigger in the monolithic environment of applications, then the handoff time, it gets longer and longer, right? So the API team, it hands off like the API to the client-side team, and it hands off the API to the other server-side team. And those handoffs, they take time. And when that time is longer and longer, then that's when you know that's a good sign of going into microservices. The other one is component imbalance. And that is something that likely all engineers here know, right? So you have your monolithic application, right? It's thousands and thousands of lines of code and hundreds of components. But you have one component that if that one fails, then you need to scale your entire application up, right? So let's say you have a review site, and once someone reviews, there is like a scoring system, or there's some kind of natural language processing or something like that, and that component is heavier than some of the components of the application. That's a clear sign that that component needs to go into a microservice. That's a clear sign that now you have a component that is dragging down your entire application. Right? It's dragging down your entire KPI, and it can go to microservices. The other one is technology decay, right? As we have a bigger and bigger monolithic application, our technology stack, it decays, right? We hear a lot, Eran and I, we share like a Slack channel, and every time we speak, I think it's about once a week, there's something new, right? And then you feel like, wait, I'm like a dinosaur here. I still have jQuery in my application, and I'm still like in Ruby 2.0. What is that? And when you need to upgrade, and when you have like new technologies that no longer serve you as they should, that's when you know that, let's say you want to build another component, then use the technology that you have on hand right now, and don't worry about the rest of the application, basically. So, if Go is really hot right now with microservices, and it does a lot of beautiful things, and it kind of connects beautifully with Docker and with minimalistic images and stuff like that. So if you have a service that can use that, just use it and create a microservice for it. But engineers, we're like tickling our fingers all the time, and we want to introduce microservices. So I'm sure you want to, but you have to always ask yourself whether you need to or not. So now once we have that out of the way, let's talk about all the stuff that you need before you introduce microservices. And this is kind of a checklist, a generic checklist of everything you need before you even start. And I'll start with monitoring, which is, and I believe this is a really true statement. Monitoring system needs to be more available and scalable than all the system being monitored. That's Adrian Cockcroft from Netflix. Now, if you have a monolithic application that talks with servers, what are you monitoring? You're monitoring CPU, you're monitoring memory, maybe you're monitoring disk utilization, right? But that's all really, really basic stuff. So when you have a microservice kind of architecture, what else do you need to monitor, right? So you need to monitor messages being sent and messages being received. You need to monitor the rate of messages being received and being sent. So you need to monitor a lot of stuff, right? And most of them are not really related to your machine. They're more related to how your services communicate with each other and how your services communicate with your data stores, right? And that's after you have your machine set up, right? So you have a machine, and that machine hosts 4 or 5 services, so you need to monitor that machine, and then you need to monitor all the messages. But, that being said, I want to talk about something that is not usually discussed when monitoring is discussed, and that's alerting, right? When do you alert your engineers? And I'll share a short story about my marriage. Anyone knows what WhatsApp is, the application? Everyone, right? So my wife has WhatsApp, and she's a member of, I think, 5 or 6 or 7 or 15 or 55, I don't know, groups, right? So there's a kindergarten group, and then there's the ladies in the Silicon Valley, and the wives of engineers, and the wife of Israeli engineers, right? All of these groups. And every time at around like 4 to 5 p.m., or 4 to 6 or 4 to 7 p.m., her phone just does not stop. It's like, ping, 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 messages and messages and messages. And that always reminds me of having too much monitoring. So what does she do? She turns her phone to vibrate. So now there is something important like me, right? No one more important than me in this world of our marriage. Well, she is, but so now I need to get a hold of her with something important about our kids, and I can't, because she has too many alerts. So what I do is I do find my iPhone, right? I find her iPhone, and I do play sound. Yeah, that's what I do. I'm not kidding. This is a true story for my life. I'm having a lot of pain here. And that's how she knows I'm looking for her, and she needs to get back to me. And that, that's something to think of. Thank you for the tips. Thank you. You see, this was worth it. Thank you all. Thank you. So that always reminds me of having too many alerts, right? And too many not important alerts. And when I started setting up monitoring, I got like, I don't know, 1,500 emails a day. Hey, this disk is doing this, and hey, this disk is doing that. nothing really important to me. So when you have a monitoring system, it's not enough to just monitor everything. You need to really pick and choose what do you alert on and what do you act on, right? So some of the stuff might not be important enough to alert during work hours and during night hours and stuff like that. So that is something you really need to look at, in my opinion. Sorry. The other thing that, when we discuss microservices that is super, super important is logging. Now, what do you need to log? First of all, I would recommend, and we had a discussion with our kind of group on Slack, is that with any service that has HTTP on it, have Nginx in front of it. Even if that service has its own HTTP server, always have Nginx in front of it. You get so many things for free. You get the access log, you get the error log, you get like the most reliable piece of software probably introduced in the last 10 years. And now that you have a microservice, then you have your monolithic application, and then you have all those microservices that this monolithic application talks to. You can tag your monolithic application with a request ID, like a user goes to a page and it has a request ID. Now this request ID gets sent to all of those microservices. So you can track one user click or one user request through all of your microservices. And that's a good way to know when something dropped. And that's a good thing to monitor, right? So you have a request ID, and then after 2 minutes, you check with all of your services whether this request ID was processed. And if one of them is not being processed, then one of your services is down. The other thing that people don't even think about is when using SQL, right? So either you're using SQL, like MySQL, or Postgres, you can add a comment after your statement that will tag service name, file name, and method name. So now you have all the query log from all the services, and like, hey, this service is doing that, and this service is doing this. Even though you have one central database, you can track which service is calling and inserting or doing whatever. The other one is composing. I would still do it because it really is, and I have the storage in the next slide, like what type of storage do you have for microservices. I would still go ahead and do it because then you have so many things that you can look at and so many things you can monitor, and you can turn it on and off whether you have performance or not. The other thing is composing all of the logs into one central location. Now with Kibana and Elasticsearch, we have like a lot of open source solutions that do that. And the other one is, we talked about messaging between services. Just log all the messages that are being transferred between services so you know which service dropped your request. One other thing that you need to look at is how you communicate between your services, right? This is something that is, I would say this is a critical intersection in any service definition. Whether you communicate to it with HTTP, right? So you have your application and then you have your service and they communicate with HTTP. Or you have messaging and then you basically communicate with the application, message queue, and a service, and they basically communicate only through the message queue. So going back, a couple of slides here, I would say that if you need to ask your service something, if your service holds state and holds data, use HTTP, right? Because then you can communicate with the service, get the data from it. If you don't, and your service only decorates some data or handles, some other type of event that you don't really need to have in real time, or you need to query it, then use a messaging queue. And I have this slide here. What about the client? So when you have a client-side application, like a JavaScript application that communicates with your monolithic application, One thing that most people overlook is, how do I communicate from the client side with my services? Do I communicate with the monolithic application, and that monolithic application basically directs the request to the services? Or from the client side, do I communicate with each and every one of the services? So for example, if we take Amazon, right? So they have the cart. That cart is calling a microservice. It's not calling the monolithic application, which they don't have anymore. So I think a good pattern to have is to start with your application calling the microservices if they hold the state, and use reactive programming to kind of handle whether the services are down or not. So for example, if you have an authentication service and that authentication service is down, then you'll have like hello guest and not hello your name. And then you can kind of react between kind of those type of events. Yeah, so now I want to talk about Datastore, and I am, so one talk that I highly encourage you to look into is turning the database inside out with Samza. Samza is an open source solution. It comes from LinkedIn, but that solution is not really important. What's important is the kind of the points that are discussed in that talk. And that's exactly what you talked about, whether we break our database or we use one central database. And that guy discusses it in length, and it also has a text blog post, so if you're more comfortable reading, so go ahead and check it out. So let's talk Datastore. This is an n-type pattern. But that being said, before I get torn to pieces here by this table, I think this is something you can definitely work with, and you should work with in some cases. So, like Udi said, he said, when you have microservices, the idea is to break not only the code, but to break the database into pieces, right? So don't write to a single place, but first tear open the database into multiple databases, and then tear the code into multiple pieces of code. And I think that's really the way to make sure that you don't ever have any microservices in your company. That's a sure way to not have any microservices, especially in smaller organizations. And I think that having a central database that all the microservices talk to and your monolithic application talk to is definitely something you can work with. Let's take an example though. So we have a review site, right? And once you post a review, that review has a description. That description is free language, right? So it goes into the database, to a SQL database, I'm sorry for that. And it has a row which has a rating, a description, and then it has a column named language, right? And that language, you say, okay, so now I need to set the language. I need to process the description, and I need to set the language. But if you say, okay, so now let's break the database first, right? And we had the discussion when we kind of reviewed the presentation, and I gave that controversial slide, is that first break it open. Now put it in a service, put it in Redis, put it in MongoDB, God forbid, put it somewhere that is not your central database. And I definitely think that break your microservice, have that code, set that language on the same database that your monolithic application reads and writes to. I see no problem with that, other than the problems I will mention. But if you keep a protocol for that, I definitely believe this is something you can work with. let's talk a bit about like advantages and disadvantages for that. So disadvantages for that are kind of obvious. You have one central point of either failure or slowdown, which if you have many, many services writing to the same location or reading from the same location, then you will eventually have a slowdown. I would pick and choose the situation where I say this is good. And I would say that if I can have a rule of thumb for you, will be that only have that for data you need for your monolithic application available immediately, right? If you query on those fields and if you have to analyze on those fields, then those fields should live where the rest of the data lives, right? They need to live with the rest of the data, or otherwise you will never be able to query them. The other thing that you will encounter is race conditions, right? So let's take an example. You have a review, surprisingly enough, and that review gets inserted to the database, and once it gets inserted, we publish an event to all of the microservices saying, hey, this review has been submitted. And then the other microservices, they go to the database and get that event. And while they do that, that event is not there. That review is not there because it was inserted, but the database was not committed yet, right? And that's not even talk about master-slave replication, whether you have your services reading from slave and writing to master. So this is something you will need to encounter, and you will need to fix in your microservices. The other is having one database per context. So one database per a group of services that discuss the same context. So for example, if you have a scoring system or a cart or orders, and all of the microservices that handle orders, they will have their own database. But then again, you will need to communicate with them only with HTTP, right? The good thing with it is that now, whether you decided 5 years ago to go with MySQL, and now you're probably in jail, but now you can use whatever database you have at hand with your microservices, right? So you can use RethinkDB and have microservices register on SQL and push events to your clients, right? So now you can use whatever is available to you, whether open source or commercial solutions, and you can use that in your services. There's a disadvantage of that, and that is coming from someone who is not only engineering those solutions but operates them, is that it's an operation hell. So now you need to deploy those databases, you need to monitor them, you need to log them, you need to make sure they're up, you need to make sure they're available, right? So it's really an operation hell. So if you don't really have an ops guy, gal, team that really can handle those situations, then you're in for a world of hurt, right? And the other thing we need to discuss here is how do we handle legacy, right? So let's talk about, now we have 30 services, right? 30 services are using 6 different databases. This is not rare, what I'm saying here. This is something that happens, right? One is using MySQL, one is using MongoDB, one is using RethinkDB, one is using DynamoDB, whatever, right? So now you have all these services that are dealing with different databases. How do you make upgrades, right? You took the legacy problem and the code decay problem and the solution decay problem and you multiplied it, right? Instead of having one problem, now you have 6. Right? Instead of fixing one bug and provisioning machines, now we need to fix one bug and provision 60 machines, right? So this is something that it could become a real operation hell and real reliability hell. And that's before even talking about security patches, upgrades, stuff like that, right? So again, you have this, you have that, you make the decision. One other thing is that you will need as a checklist item is discovery. Now, discovery is an overlooked subject, and it's really, really complex. It seems simple at first, yeah. So, but let's make the definition first. So, service discovery is a key component of most distributed system and services-oriented architecture. The problem seems simple at first, and I agree with that. How do clients determine the IP and port for a service that exists on multiple hosts? Now, that service doesn't really need to exist on multiple hosts. Even if it exists on one, how do you know where it is? How can you tell your application where it is without, pointing to an IP? So in that, there are many solutions, and again, I will make it short because, again, the other ones will physically abuse me after that. So there are multiple solutions here of how do I find service X or service Y, and I highly encourage you to use DNS for that. DNS has been around for a while now. That's how you find your websites. That's how you find Facebook. That's how you find Google. DNS is the way to go, right? So I would recommend having an internal DNS solution where services register, and then the other applications can find them. I will not go into hardware utilization because I don't have time. But let's talk about configuration management. And this is something which I discuss with everyone I discuss microservices with. When you have a machine, the configuration management is easy, right? You have your packages, you have your dependencies, and you have your application, right? That's it. You have one type of machine. But when you have a microservice, what is a service? Does that sound familiar to you? Oh, okay. What is a service, right? What does a service need? What do I, as an engineer, need before I deploy a service? So I'm not just asking a question in the air here. So your configuration management really is about definitions that I, as an engineer, do not need to worry about, right? You will need to define what is an HTTP service, what is a messaging service. You will have to define kind of internally where do those services are deployed. But as an engineer, all I will need to do, as you as the ops guy, you will need to give me that. I will need to say, hey, I have this service is deployed, right? That service will be monitored, that service will be discovered, that service will be version upgraded, the machine will be utilized, everything, right? So now your configuration management is also getting more and more difficult. And I realize I'm kind of, starting to discourage you here a bit, but I'm simply giving you the tools and the checklist to discuss internally when you go into microservices. Two final things. One is CI. Everybody talks about the code, right? We have the services, we have the discovery, we have, the code is deployed. But now when you have a lot of microservices and a lot of machine definitions and a lot of service definitions, now CI is one of your most complicated pipelines in the company, right? That CI is now building images, deploying, building services, building Dockers, communicating with DNS, right? Now this is your most complicated feature, right? So you need to really make sure that your CI solution can handle that, and you need to make sure what do you put on that CI, right? Let me give you an example, right? So we have machines, machine provisions with configuration management, but a configuration management is a multiple story building, right? So you have the base, and then you have your packages, and then you have your application dependencies and stuff like that. So if you kind of wait to provision a machine, you have your 5 or 6 minutes turnover time. But if you put your CI and you say, you know what, every couple of hours you build the base, and then every couple of hours you take that base and you build the dependency on it, which is my application, and you build the services. And then as you go through the day, your kind of application dependencies and your machine dependencies are being built all the time. So now when you need to provision a new machine or when you need to provision a new service, that is available to you. You don't really need to have that turnover time of 5 or 6 minutes before you provision a machine. Last thing is culture. And I think culture in almost any company, regardless of microservices, is super important. But I want to discuss something Bezos said in an email to the entire company. Right? He said this: all team will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through these interfaces. There will be no other form of inter-process communication allowed. No direct linking, no direct read of another team data store. No shared memory model, no backdoors. The only communication allowed via service interface calls over the network. Anyone who doesn't do this will be fired. Thank you and have a nice day. Now, if you're Bezos, you can afford that type of culture. But if you're not, then you really need to encourage communications between the team. And again, we kind of brushed on that during this presentation. But now teams, instead of communicating with words and, hey, this is my data store, they need to communicate with contracts. Hey, this is the contract I need. This is the contract I'm expecting. This is what you're sending me. This is what I'm expecting back, right? So as your team communicates, that's how your services will communicate. Yeah, and I know I made it a bit short than I needed to, but yeah, that's what it is. So thank you.